Okay, so next thing we're going to talk about are clamper circuits. We call them DC restoration circuits. So if you remember when I was showing you the signal generator, we're capable of having an AC signal and also mixing in a DC voltage with it. So normally when we talk about like AC, like for instance something coming out of the wall, I'm just going to use this example here. This could be your AC coming out of the wall, where this would be like 120 volts RMS. So what normally, if you look on the live, current goes back and forth. So for 8 milliseconds or so, current is going in one direction, and then for the other 8.3 milliseconds, current goes in the opposite direction. All right. So there's no DC coming out of off the receptacle. It's purely AC. But it doesn't mean that you can't have a signal that has both of them, an AC quantity and a DC quantity. So you could take a wave and then elevate it. So for instance, I've got something here where I've got a wave that is, 10 volts, 20 volts peak to peak, but has a DC level of 10 volts. And it starts at 0, goes up to 20, but the current is always going in one direction. The current never reverses. So it's possible to have an AC signal with a certain amount of DC in it. Okay? Now, these clamper circuits will permit you to take a signal that has no DC content in it, and you can take AC and add a certain amount of DC to it to elevate it. So I'll show you how they work. So for this particular circuit, I've got a capacitor, diode, and resistor. Resistor, I'll make it quite large, say a megohm. This is an example. And to make this circuit kind of work, I'm going to start, I usually start at 0 degrees, but I'm going to start my wave on the negative. So I'm going to start over here and then work my way through. So I'm going to start going negative first. So I'm going to start with this half cycle because I want the diode to conduct. So if I start off with this, current is going to flow, it's going to come over here, and it's going to have a choice. I've got a diode and I've got a large resistor. It'll choose the diode because the diode kind of looks like a short circuit. So current will flow this way, get to the capacitor, and if we had, let's say we had 10 volts, polarities plus, minus like that, we'll assume in this case, for this particular explanation, I'm going to assume an ideal diode. So with an ideal diode, we'd expect the capacitor to charge up to 10 volts plus negative this way. If we were doing this circuit in the lab, it would charge up to about 9.3 volts because we have lost some voltage forward biasing the diode. Good? So far, so good on this? All right. So now we're going to turn the polarity around. So now we're going to go to this half cycle. Now we're on this thing. And we're going to go plus 10, plus minus this way. So now, what I'm going to read, if I read on the output, well, if I take this path, what I see is plus 10, plus 10. So it goes up to plus 20. So what this circuit essentially does is it takes my sine wave that was centered around 0 volts and it clamps it up so that it goes from 0 all the way to 20 volts. I still have 20 volts peak to peak, just like I had at the input, 20 volts peak to peak. But this time, because of the capacitor and the fact that it charged up it clamped my signal up, so it gave it 10 volts of DC voltage, and it clamped my circuit. All right, so that's how a clamping circuit works. All right. So we'll do a variation of that. So these are going to be the type of circuits I'm going to give you next week. So we're going to try those out in the lab. We did clippers this week, so we'll do clampers next week. Okay, next circuit. Again, we'll assume an ideal diode. And I'll set my power supply to say 2 volts. 2 volts DC. Okay. So I'll start off on the negative cycle again. Start off on that. So current will start flowing this way, and it can flow because in this case the diode would be forward biased. So if I have, for instance, at the input, if I have 10 volts this way, plus minus, so this is pushing that way, but the DC power supply is pushing that way, what does my capacitor charge up to? That's what I think. 8 volts. Okay? So when the polarity flips, plus that way, goes this way, well, nothing conducts through here, but what I'm going to read is from here to here, I'm going to read plus over here, plus 8, plus 10, so this thing would be clamped up. So it'll go to plus 18, and the other half would be at -2, right? Does that make sense? Maybe not. Maybe not. Plus 18 there. So it'd have to be 20 volts peak to peak. Yeah, makes sense. Just be your 0 volts down here. Does that work? Any questions on that? Okay, so I'll give you one to try. So, we've got this here at the input. And we'll, 13, -13. So I get a sine wave right at the input, plus 13, negative 13. I've got this circuit here, and I've got a negative 5 volt DC power supply. So what's my output wave? Figure that out.